Here's my circuit with the power pack here producing a current coming out the red terminal. Around the circuit it passes through the lamp and comes back into the black terminal of the power pack. I'm going to turn the current on and the lamp lights up. The electric current is a flow of charge that is transferring energy. Now we're going to think about how much power is being transferred in the circuit. Now power is the amount of energy transferred each second. So it's measured in joules per second. Power is measured in the number of joules per second, or we also call this watts, which is W. All right, watts, W. Now what we can measure in this circuit is firstly the amount of current flowing. So let's do that. To measure the amount of current, remember I have to flow the current through my ammeter that is going to measure the current for me. Here we go. So when the circuit is connected, we have 0.05 amps. You can see that on the ammeter is flowing. I'm going to write that down. The current is 0.05 amps. Remember that 0.05 coulombs of charge per second is flowing around the circuit. Now let's measure the potential difference across that component. So I have to reconnect the circuit. I want to know how much energy is transferred as that amount of current flows through the lamp, which is where the energy is transferred. So to do that, I measure the voltage by comparing the energy of the charged particles on either side of the lamp. And I can see it's coming up at 4.6 volts. That's the change in the energy of the charged particles as they go through the lamp. I'm going to write that down. The potential difference is 4.6 volts. Remember, we can also write that as 4.6 joules per coulomb. Each coulomb of charge transfers 4.6 joules. Now I want to know the power, which is how many joules per second. Well, I've got coulombs per second and I've got joules per coulomb. I want to know, firstly, how much energy is transferred in the bulb by each coulomb of charge. That's my potential difference. And then I need to know how many coulombs of charge are going through to work out the total amount. Well, that's my current. So if I do power, which I'm going to give a big capital P, is equal to the potential difference, which is V, times by the current, which is I. So this is equal to 4.6 joules per coulomb, or volts, times by 0.05 coulombs per second, or amps. Let's do some quick maths on this. This is going to equal 0.23 watts, or this is 0.23 joules per second. So each second with this circuit, my lamp is transferring 0.3 joules of energy from the charged particles that are going through it to a mixture of light and heat, which are coming off the bulb.